Hello everyone, this is your Lekkala Mastaru. In this video, apart from the regular topics, I am going to explain one strange and hard-looking geometry problem in this video. The reason behind choosing this problem is the concepts whatever we are going to use to solve this problem are pretty simple concepts. You will be surprised to know that concepts, how these simple concepts will be used to propose this hard-looking problem. That is the thing I want to let you know from this video. So now, before going to explain the question as well as the solution, first let me recall those simple concepts. That is the very simple thing which we are learning right from our 7th class, that is area of a triangle. Whenever a triangle is given, the basic formula which we use to calculate the area, that is half into base into height. Not only for acute angle triangles, if you take any right triangle apart from hypotenuse, the remaining two sides were considered as base and height to calculate the area, especially when we are using this particular formula. And if you see the word right triangle, as soon as you see this word right triangle, immediately we used to recall one important theorem, that is Pythagoras theorem. So in any right triangle, square of hypotenuse is equals to sum of squares of the remaining two sides. Is the statement of this theorem which is familiar to all of us and most popular theorem also in geometry concepts especially. Now, just area of triangle is half into base into height, and that formula can be applied for right triangles also. In right triangle we can apply Pythagoras theorem. These are only the things what I am going to use to solve this problem, whatever I am going to discuss now. So let me keep these two topics aside. So now first let me explain the question here. A, B, C, D is a quadrilateral given to us. In this particular quadrilateral, angle D is 52 degrees and angle C is 38 degrees. And AB length is root 3 and CD length is root 5. And one more information, AD length is equals to BC length was given in the question. So let us suppose assume this as x and this also will be x only. Now they are asking to calculate the area of this particular quadrilateral. If you see clearly, even the angles whatever given to us are abnormally looking. Why? Because usually we used to work with 30 degrees, 45 degrees, 60 degrees, the most familiar numbers, especially in the sense of angles. But here 52 degrees, 38 degrees were given. They are asking to calculate the area. If you see this diagram, this is not any in parallelogram shape or square shape or rectangle shape to use any particular formulas. So still they are asking to calculate the area of this one. So if you take these two angles aside and if you make the sum, we are going to get 90. So as it is quadrilateral, sum of two angles is 90 degrees, means sum of rest of two angles will be 270 degrees. Here we are supposed to think a little elegantly to calculate the area. When the angles are abnormal, when the shape is abnormal, still there is a possibility to calculate the area of this figure. Here what I am thinking, instead of quadrilateral, if it is any triangle, as the sum of two angles is 90 degrees, definitely third angle is going to be 90 degrees. Definitely that triangle is going to be right triangle. In this sense, I am approaching this problem just thinking little beyond this one without disturbing these two angles. What I am doing here, this DA and CB sides I am producing so that they are going to meet at some point P. So now if you see the triangle PCD, angle C is 38 degrees and angle D is 52 degrees, whose sum is 90 degrees. Definitely angle P is going to be 90 degrees for us. So which means PCD is a right triangle. Now here this part is x, this part is x. Just let us suppose PA length is y and the PB length is z. So definitely this complete length is going to be x plus y and this complete length is going to be x plus z. Now how will you calculate the area of this particular quadrilateral here? Simply you can say from the entire PCD triangle, if I remove PAB triangle, we are going to get the rest of part which is the required quadrilateral. So first let me write area of ABCD is equals to area of PCD minus area of PAB. So how we are going to calculate with the help of formula only, but no information, especially no numerical information was given about the legs of these two right triangles, but no problem, with the help of Pythagoras we can make it possible. So here what I am doing here, see the small triangle PAB. So y is there, z is there, hypotenuse root 3 is there, angle P is 90 degrees. So I am mentioning in triangle PAB, y square plus z square is equals to root 3 whole square, which is nothing but 3. That what I am writing here, y square plus z square is equals to 3 according to Pythagoras theorem. Let me make it as a statement 1. So in this triangle I got y square plus z square is equals to 3. Now let me consider whole triangle PCD triangle. In this triangle, in triangle PCD, what is one side? X plus y. What is other side? X plus z. What is hypotenuse? Root 5. So x plus y whole square plus x plus z whole square is equals to root 5 whole square, which is nothing but 5. So just applying algebraic identity a plus b whole square, x square plus y square plus 2xy, x square plus z square plus 2xz is equals to 5. But with the statement 1, we can replace y square plus z square with 3. Here if you observe y square plus z square, I am replacing with 3. Rest of parts, x square and x square, 2x square, 2xy, 2xz is equals to 5. If I transpose 3 to this side, we are going to get 2x square plus 2xy plus 2xz is equals to 2. If I divide with 2, we are going to get x square plus xy plus xz is equals to 1. So let me make it as statement 2. Now coming to here, area of ABCD is equals to area of PCD minus area of PAB. We wrote here PCD x plus y and x plus z are the sides which will be considered as base and height. For the triangle PAB, y and z will be considered as base and height. That what I am writing here, half into x plus y into x plus z minus half into y into z. If I take half common and if I reopen the brackets, we are going to get x square plus xy plus xz plus yz minus yz plus yz gets cancelled. We are going to get half of x square plus xy plus xz, where statement 2 says as x square plus xy plus xz is equals to 1. That I am replacing here, half into 1 is equals to half, which is nothing but half square units is the area of required quadrilateral ABCD, in which AD is equals to BC and CD is root 5, AB is root 3, whereas the angles are 52 and 38 degrees. So my dear children, if you observe carefully the entire solution, just Pythagoras theorem and half into base into height, only the two simple concepts what we used to solving of this problem. So you can understand how beautifully based on a simple concept the hard looking elegant problem was created, and how innovatively we produced these two sides to find out the area of required quadrilateral that we are supposed to understand and learn behind this problem. Hope you enjoyed this solution and problem. So we'll meet in the next video with another topic. Until then, take care. Bye bye. You are Lekkala Mastaru. Haragopal.